Good, myself Amboji. We are here with a presentation on develop a small image classification ensemble combination CNN and SVM hybrid model. These are our team members Chetan, Rajat and Sayed Hashim. And these were content. While coming to introduction, teaching computer to look at a picture and tell what is it. For example, showing a dog image model to predict computer to see. In deep learning, use many layers of artificial neural to learn from large amount of data. Are specially type of deep learning models that can see pattern in images. They make classification accurate and powerful for identification of the image. Next, we are coming to traditional method like support vector machine SVM still offer blueprint, especially with limited data. Before deep SVMs were commonly used for classification tasks. They still work well when there isn't much data or computing power. They are simple, stable, and effective in certain cases. In this project, aims to meet both CNN and SVM method. CNN will extract important features from the images. SVM will then classify those features into category to predict the image. This combination can make the system more accurate and reliable than using either one alone. Next slide will continue by Sayadash.
We have problem statement. Here in the problem statement, we will have the challenges to ensure image classification accuracy and generalizing across the dataset like MNIST and CFAR 10 and fashion MNIST by leveraging the deep features extraction from the datasets and the capability of the CNNs, despite this tendency to the overfit small datasets and the robust classification of the strength of the SVMs and the which lack with the abstract features like learning thoughts hybrid models and some of the combines the complementary advantages. So here we have the problem statement like we will combining the CNN and the SVM to the better understanding in the small data sets to uh, get the accuracy and the foster performance. Next slide. For the objectives, we have developed a hybrid model. So we will design and implement an ensemble architecture that integrates CNN for the feature extraction and SVM for the classification to enhance the image recognition accuracy. So next we will reduce overfitting. For the reducing overfitting, we will utilize the data argumented and ensemble prediction techniques to minimize the overfitting, especially on smaller data sets. Likewise, for evaluating the performance matrices, we will assess the hybrid model using accuracy, precision, and recall F1 score. These are the confusion matrix we will use to validate its effectiveness and the compared to the standard CNN and the SVM models. So next slide will be continued by Rajat.
We discuss about literature survey where technical concepts are CNN, convolutional neural networks and insights. It achieves state of art performance. Means that CNN model have achieved state of art performance in image classification. It gives more state of image classification. And SVMs support vector machines that perform well in high dimensional spaces. In high dimensional spaces and small data sets. Hybrid model is the combination of CNN and SVM, which perform both state of performance in image classification and small datasets. Ensemble techniques. Ensemble techniques help us to reduce the model bias and enhance predictability through combined outputs. Ensemble techniques combine the both CNN and SVM and help us to reduce the model bias. In methodology, Data collection and pre-processing. In the first step, we collect the data and pre-process it for future extraction. In future extraction, we import visual features for interact processing of collected data, where we classified two types, CNN and SVM training. In conventional neural network training, we classify the data, and in SVM training, we classify data based on their particular characters. In production fusing, both the results of the CNN and SUN were fused, means combined. And in last step evolution, using predicted metrics, we take the accuracy test by accuracy, precision, and recall. Next slide will be continued by Chetan.
Requirements. In that software requirements like Python, this is main programming language we can use. Next one is TensorFlow or Keras, deep learning framework for building a CNN. Next is scikit-learn, a machine learning library especially useful for implementing the SVM. Next is hardware. In that GPU enabled system. In that CNN are computationally heavy, especially during the training. A GPU speeds up this process significantly. Next is data sets. In that MNIST, it is handwritten digits. Next is CIFAR 10. This is color images in 10 data sets. Next one is fashion MNIST. This is article images like shirts, shoes, and etc. Next, next is libraries. In that NumPy for numerical operations. Next one is matplotlib. It is used for plotting and visualizing the results. Next one is OpenCV. In that for image preprocessing and manipulation. Next slide. Conclusion. In that the model is combines CNN and SVM. In that CNN, it extracts the features and more effectively than a typical images. And next is SVM. It is more effectively than a typical software layer and it can improve the accuracy, better performance on test data. Next is reduce overfitting. It generalize the well to unseen the data and enhance generalizing works across the different data sets. Next, Ashim will continue the code.
The code. This explains the data pre-processing of the MNIST of datasets of handwritten digits is loaded, and here we can see 0 or 1. 0 or 1 is the normalized to 0 or 1. Next we reshape it and fix the CNN input to the formats. Like discuss the model, here we train the CNN quickly, and with the CNN and SVM we will get the Apache 3. These are the three Apache we will get here. Next, coming to the future extraction, we will use the models like input and output for the features. Like we will train and test the features, so it will take some time. And next we will upload the SVM classifier for the classification of the true or false verbals. This is the probability the verbose. So here next we will go for the ensemble of the average probabilities. So here it will take some time. Next we will get the accuracy of the CNN and the SVM. So here in the conclusion we will say that the accuracy of the CNN is 98% or 99%. And accuracy of the SVM for the macro average, we will say that accuracy is 99%. So hybrid accuracy of these slightly to the 99.8% we will get, but this we will get 99%, showing the improvement performance and through the ensemble learning. So this is all about the SVM and the CVM datasets. Thank you.